Hello all. Today we are going to talk about game theory, and it's a very interesting subject. And we have a guest, Zeynep Yener Gök, who teaches game theory class at our department. So she has lots of interesting things to say, I believe. Without further ado, we can start whenever you want. Zeynep Hocam.
First of all, thank you very much for inviting me to your class. I guess I can share screen, right? Okay, I prepared the presentation and
Okay.
This is the class of game theory. Today we're going to talk actually a brief introduction to game theory, what game theory deals with, what is its concerns, and we're going to see some classical games, actually 3 classical games of the game theory. We're going to talk about the assumptions and what game theory is, and a little bit of history, but I want to start with a game since this class is about game theory. I would really appreciate if you all join in. So I would like you to assume that your grade for this class will be based on this game. That's what I talked with Hüseyin Hoca, and he agreed. Okay, rules of the game is each of you are supposed to choose either of these 2 letters, X or Y. And you can think of this game as a grading bit. Your choice of the letter will be randomly paired with one of your classmates, and none of you will know whom you're paired with. Here's the grading policy. If X is paired with Y, the one who chooses letter X will get an A1 from this class, and the partner will get C2, and the opposite is true for if Y is paired with X.
Zeynep Hocam, I can't see the presentation.
You can't see the presentation.
Maybe it's my fault. Can anybody see the presentation?
Okay. Let's try one more time. Can you see it now?
Started? No. Okay, it's here.
Okay, then let's go like this. And actually, I want to. Is it okay if I go like this because I want to open the chat box to here? This would be more convenient for me. Is it okay for all of you?
Okay.
Okay.
Yeah, I can see the presentation now.
Okay.
Okay.
Here's the game. Your grade for this class will be based on this game. The rules of the game: you're supposed to choose either of the 2 letters, X or Y. And your choice of the letter will be randomly paired with one of your classmates. None of you will know who you are paired with. And the grading policy goes like this. If X is paired with Y, the one who chose X will get an A1 from this class, and the partner will get C2. The opposite is true for Y paired with X. If 2 X's are paired, then both will get B3. If Y is paired with Y, then both of you will get B1. Which letter would you choose and why? You can talk or you can write in the chat box.
No one is willing to say anything.
I guess so, right? That's right. Why is that?
Okay, I would choose X, for example.
You would choose X.
Yeah.
We assume that you are a student, I guess, right?
Yeah.
Okay, why would you choose that?
Both student and teacher. So I will get A1 no matter what.
No matter what is the...
I felt like it.
You felt like it. Anybody else? Isn't there with us? Okay, no one is joining. Here's the game metrics. This is a simultaneous game. which means that pairs are playing at the same time, or maybe not at the same time, but at different places without knowing what each other chose. This matrix shows you the players and the strategies of the players. So here, your choice and your strategies of choosing X and Y. These are the payoff of the players. The first payoff is the player's once payoff if this outcome happens, which means that if you chose X and your pair chose X2, you will get B3. And your pair's strategy is if it's X and your choice is X2, your pair will get B3. Here are the letters. Maybe now some of you may want to join. Is there anyone?
This is not an exam, just an example.
Yeah, it's not an exam. It's just
talking.
a game. It's just a game.
No.
Okay. On the right matrix, you can see the payoffs using utilities, maybe, or the number payoffs. Here, if both of you choose X, you will get a payoff of 0, each of you, which may be interpreted like everyone in this class will get B3 as a default. And the other payoffs are maybe interpreted like increase or decrease in your grades. So when you choose Y, while your pair is choosing X, then you will get -1, which means there's a decrease in your grade. And your pair will get 3, which means there's an increase in his or her grade. That is A1. Since there is no one playing in this game other than Hüseyin Hoca and me, we can see that X strictly dominates the strategy Y. What does that mean? If, as Hüseyin Hoca mentioned, he would get the most payoff, the highest payoff, no matter what. Strictly dominates means that no matter what. If you choose X and your pair choose X, you will get 0. If you choose Y while your pair is choosing X, then you will get -1 as a payoff. And this will make you worse off, so you would choose X. Let's assume that your pair chose Y. Then you would again choose X because it gives you higher payoff than you would choose Y. So since X strictly dominates Y, everyone would choose Y in this one. And a rational player never plays a dominated strategy that is Y. I asked here why is that on the assumption that everyone joined in this game, but since no one joined, I'm putting a statement here. If me and my pair, well, if you choose the dominant strategy, both of you get payoffs of 0. However, if both of you choose the dominated strategy, you would get 1 as payoff, which is a higher payoff than the dominated strategy. So if we reason this way, why, if we behave a different way and choose Y, then we'll get both 1. So I should choose Y. Is this a correct statement? Or is there something wrong with this statement? Does anyone want to join?
No.
No? So actually, it involves some kind of notion of agreeing. I'm telling you that if I reason this way, then I'm assuming that you would, I'm not sure about my pair's choice. Could you elaborate that part?
Actually, I think like I can choose Y, but I'm not sure about my pair's choice. So he or she would choose X, and so that way I'll get -1, and he or she'll get 3.
3, and you will get a less payoff than you would have if you chose the dominated strategy. That's right. So what is wrong with this argument is it involves agreeing. I'm assuming that you will behave the same way, but I cannot guarantee it, just as you said. The second you choose X or I choose Y, someone may take advantage of this decision. I would prefer to choosing X because I know that I will get a higher payoff, and I cannot guarantee what my partner chooses. So rational choices actually may lead to inefficient or worse or bad outcomes, even though when we are talking about game, we can say that there's losers or winners. In this game, even though there are a higher payoff, everyone comes out as losers. And this is an example of prisoner's dilemma, which is a very classical game in game theory.
So I'm sorry, could you repeat that part? You know, the rational strategies will lead to inefficient outcomes.
Yes. We'll come to assumption of rationality. What does that mean? And we'll go over the original story of prisoner's dilemma in a bit. This was just a game for fun, but since nobody has joined it, it lasts so short.
There's no fun. Okay, that's fine.
Okay. So what is rational?
Maybe you know they may have encountered with a game theory example first time. So maybe
Perhaps.
We can start from here. What is game theory? That's the most important part, it seems.
Yes. What does that
But that principle is very important. You know, this prisoner's dilemma thing. The best outcome may lead to not so best. I'm sorry. The best strategy may lead us into some kind of bad things.
Or worse outcomes.
Yeah.
Okay, when we are talking about the word game, we may get the impression about gambling, sports, or childish games or so. But since the world of full of important stuff like wars now we are experiencing, or relationship, education, business, game theory actually involves these too. It helps us understand these weighty matters actually. Most games include chance, skill, or strategy in different proportions. For example, tossing a coin is pure chance, and a 100 meters dash is pure skill, except for the external effects of obviously. However, strategy is different kind of skill. It's about interactions with others, just as in the game that we just played. And as they do similar thinking about the same thing and about the same situation. So it's actually the analysis of interactive decision of rational individuals. It's a method of studying strategic situations, which strategic situation can be defined as a setting where the outcomes that affect you depends not just on your own actions, but also the actions of others that you interact with. What is not a strategic situation? For example, if you have seen now, firms in perfect competition are price takers. So they don't involve any strategic interaction, and monopolists are similar to, there is no strategic behavior in them. However, BMW has to worry about what Mercedes-Benz is doing, or in terms of pricing, research and development, and new models of cars. So that involves kind of a strategic situation. So since game theory, the behavior of decision makers in the economy, those decisions affect each other. So a game is being played every day, everywhere in our lives, whenever humans interact. It can also be Hüseyin Hoca zannediyorum düştü. Hoş geldiniz hocam.
Ya kusura bakmayın bazen böyle saçmalıklar yapıyor. Okay, go ahead.
Okay, thank you. So game theory thinking is the study of many subjects, economic, business, political science, and even biology in the concept of evolutionary games. I didn't go into that right now. The basic assumption, as in the mainstream economics, is rationality. The aim of a player in a game is to achieve as high payoff for himself as possible. That is what the rationality assumption tells us. So each player is calculating the strategy that is his own best interest, and he is very good at following that strategy in the course of the play. That's the definition of rational behavior. So rationality assumes that, or game theory assumes that we are perfect calculators and flawless followers of our best strategies. So it has two ingredients. We have complete knowledge of one's interest and our own interest, and we have flawless calculation of what actions will best serve for our best interests. What it doesn't mean is that we are not selfish. Players are not selfish. They may rate highly the well-being of the others and incorporate this high rating into his payoffs. I can think that if I give someone, if I behave someone to get high payoff, I may increase my best behavior, best interest as well. And it doesn't mean that players are short-term thinkers, since calculation for future consequences is an important part of strategic thinking. Players think in long term, actually. And it doesn't mean that all the players have the same value as others. It just means that we are good at pursuing our own value system. When a play is in act, actually, a player must recognize that the other players calculate the consequences of their own choices by using their own value system. So everyone has different value systems. So you must impute, you must think in your own value system and assume that they would act as you would in the situation. There's an example that I found in a book about Persian Gulf conflict in the late 1990s, and which ended with the death of Saddam Hussein in the beginning of 2002. They predicted that Saddam Hussein would back down, actually, because they think that he is rational. However, they failed to recognize that he has a different value system than the Western governments and Western thinkers. So actually, each player doesn't really know what the other players' value system. They even don't know about their value system so constantly. So this may lead to some incomplete or asymmetric information. This is a tricky part of game theory, and it leads to different solutions. So how good is this rationality assumption? Is that there's a question like this. At one level, it's obvious that we cannot be all rational. Our emotions, our past experience affect our decisions, and it's sad that people are boundedly rational in this matter. They intend to be rational, but they are limited to do so. So we sometimes may end up with suboptimal decisions. We are limited cognitively, we are limited computationally, we have some imperfect limitations, imperfect information limitations, or time constraints. So rationality assumption may be closer to reality when the players are regulars or who play the same game quite often. However, if other players fall short of standard rationality, then we can exploit their situation by using rationality assumptions. So it may be safer to play rational if we are assuming that the opponent's capabilities are limited. And another assumption is common knowledge of the rules. Game theory supposes that at some level, the players have a common understanding of the rules of the game. In some games, like chess, like sports, rules are fixed, but in many of the games that we daily encounter, our rules aren't fixed. An example for this may be parents constantly making up rules for their children, and they can change the rules. They can manipulate them. So since the rules of the immediate play can be manipulated, there's another game being played at a deeper level. Whether these rules are in the deeper game are fixed. So the rules of the game consist of the list of players, the strategies available to each other, the payoff of each player for all possible combinations of strategies pursued by all players, and the assumption that each player is a rational maximizer. So common knowledge says us that there's a fact in situation X, and for it to be a common knowledge between people A and B, each of them must separately know the situation X, and each of them should also know that the other knows about X, because otherwise it can exploit the situation in their own benefit. But then A should also know that B knows that X, and the other way around, and it goes to infinity. We can give an example of common knowledge with a fable, a well-known fable called Josephine's problem. There's a village contained of 100 married couples, and we all assume that they're all perfect logicians and rationals, but there's some social customs. Every married woman knows about the fidelity of every man in the kingdom, except for her own husband. No woman should tell another about the fidelity of her husband. If a husband is ever faithful, then he and his lover would immediately inform all the other women in the village, except his wife. And everyone knows that if there's a gunshot fired in any house in the kingdom, it will be heard in any other house. These traditions are the common knowledge among the people in the village. The queen of the village, Josephine, once announced that unfaithful men had been discovered in the kingdom, and that any woman knowing her husband to be unfaithful was required to shoot him at midnight following the day she discovered his infidelity. So in fact, every husband in this village are faithful. Thus, everyone knew of every infidelity except for that of her own husband. Now, let's ask what this Josephine announcement tell the wives they didn't already know. The announcement made it a common knowledge among the women that there was an unfaithful husband. If there is only one unfaithful husband in this village, then every woman in the kingdom knows, except his own wife, who believes that everyone is faithful. Thus, as soon as she hears the announcement, she knows that her husband must be unfaithful, since she doesn't hear any gunshots at that midnight and shoots him in the other night. If there are two unfaithful husbands, then both wives believe there is only one unfaithful husband, so they will expect the other one would shoot her husband, and since there is no gunshot, then they will realize that their husbands are unfaithful. So in general, if there are 100 unfaithful husbands, each of their wives will believe that there are 99 and will expect a gunshot at midnight on the 99th day. So before the announcement, actually, every statement of the firm, wife knows that there is unfaithful husband was true for a number of less than 99, but it was not true for the whole village. So the consequence follows that, in fact, a common knowledge can be very different from the consequences that will follow if it was merely known by anyone that knew it. And here comes the classical game, Prisoner's Dilemma, the one that we just played. It's actually another game. Well, as I said, in every game there's a winner or loser, but Prisoner's Dilemma is a different kind of game. So assume that you are enrolled in a class that is graded on a curve. No matter how well you do in absolute terms, only 40% of the students will get A's, and only 40% will get B's. Therefore, you have to work hard relative to your classmates. Since all of you recognize this, you met and you decided not to agree too hard. You agreed on this, not to work too hard, not to study too hard. However, as weeks pass by, you are overwhelmed by not working too hard because you are suspicious about others working. So what would you do? Would you hit the library more often and study hard, or just let yourself not to study hard and be graded on absolute terms? Would anyone want to join this part? Okay, I guess, well, if I'm a student, I would study hard in not in only absolute terms, but in relative terms, because I would think that my friends, I wouldn't trust anyone, my friends would be studying, so I would study hard too. So actually, I would get the grade that I would have if there weren't any curve, if the grade was on absolute terms. The only difference is that I would spend more time studying, so there's opportunity cost of studying, and I would learn more stuff than I would otherwise be. Here's the original story for Prisoner's Dilemma. Bora and Ozan are the two players in this game, and they are arrested under the submission that they murdered a young woman. And the police place the suspects in separate rooms to interrogate them. The police have an evidence for kidnapping the woman, but not a solid evidence for murdering her. So the police explains to each suspect that they are looking for a jail time for kidnapping, probably 3 years, and it is written here. If there is no confession of murder in either of them. And they are told individually that the police know what they did, and they participate in the crime. So if they're also told that if both confess, jail terms would be negotiated down, but not as much as it would if only there's one confession and one denial. So each player has two strategies. They can either confess or they can deny. They both has to choose between confessing or denying. If they both confess, they will get 10 years of jail. If only one confess, he will get 1 year in jail, and the other one will get, the denying part, will get 25 years in jail. So the matrix says us that. Let's take Bora's perspective. If he believes that Ozan would confess, Bora would choose confessing. Okay, the payoffs here are jail time. So in this game, we are looking for less payoffs actually, because he would either, if he confesses, he would spend 10 years in jail. If he denies, he would spend 25 years in jail. So if Bora believes that Ozan would confess, he would choose confessing. If he believes that Ozan would deny, he would choose confessing again, because he will get 1 year in jail. However, if denial happens, then he will get 3 years in jail. By the way, I'm so sorry that these are written all wrong. This is denial and this is confess. Okay, so we believe that I'm sorry, it's wrong. So confessing is the dominant strategy here, because no matter what Ozan chooses, Bora gets a higher payoff in confessing. So even though there is a less payoff here, if they both deny, they will get 3 years in jail. However, they both confess, and the Nash equilibrium happens in this confess part actually. Prisoner's Dilemma has 3 features. Each player has 2 strategies, and this is type of a game actually. This is very important in game theory, and it happens in the life we saw in the first game, and we just saw in the grading game. Each player has a dominant strategy, and the dominant solution equilibrium is worse for both players than non-equilibrium situation, in which each plays the dominated strategy. It's actually important for 2 reasons. The payoff structure with Prisoner's Dilemma arises in many strategic situations in economics, politics, and social and biological competitions. And the equilibrium outcome in the Prisoner's Dilemma is actually bad for a rational player. If you are a rational player, then the better outcome. However, there's this trust issue. So if we are rational, actually, in types of Prisoner's Dilemma game, we are ending up with bad equilibrium. Okay, I said something like Nash equilibrium. What is a Nash equilibrium? It came with John Nash. I believe you all heard his name with the movie The Beautiful Mind. John Nash actually formulated the concept of Nash equilibrium in his graduate thesis. And the concept is mainly the center of theory of games. He had this illness, he was schizophrenic, and it kind of wrecked his career, but after a while, he hung up and he awarded with a Nobel Prize. He comments, without his madness, he calls his illness that, he would perhaps have been another of the faceless multitudes who have lived and died on this planet without leaving any trace of their existence behind. We can call a Nash equilibrium definition is an area of strategies, one for each player, such that no player has an incentive to deviate from his part of the strategy array. So rational players will seek to maximize their average payoffs, and it would be easy for players knew that strategies their opponents were going to choose. A Nash equilibrium occurs when all the players are simultaneously making a best reply to the strategy choices of the others. So why would we care about Nash equilibrium? Because as rational players, we need a solution of a game. And the second supposes that people find their way of solution by some evolutionary process, trial and error, or experience, or so. But we don't have any information about that evolutionary process. So Nash equilibrium helps us, or rationality assumption actually, helps us to predict where they will eventually end up in solution. Another example is Battle of Sexes. The story goes on like this. There's Alice and Bob. They are a newly married couple, and they're honeymooning in New York. And at breakfast, they discuss whether to go in boxing match or the ballot in the evening, but they fail to make a decision. And when they hanging around in New York, they end up separated. They don't have any cell phones or so they have no way to contact with each other. And now each has to decide independently where to go in the evening. Okay, Bob, as being a man, like to attend to boxing match, and Alice would like to attend to ballet. Each would rather attend an entertainment with the other than not at all. So the important part for both of them is to attend an entertainment together. This game is representative of many situations, and if you can see here, there are two Nash equilibria in this game. The question is which one to choose. So in games, there may be sometimes multiple Nash equilibria, and rationality assumption actually leaves us behind in this part in choosing Nash equilibrium. This is a cooperative game, a coordination game, or you can call it. The examples of this situation can be two manufacturers of complementary goods wish to adopt compatible standards, but for various reasons, each may prefer a different sort of standard. Or a labor union and the management of a firm may be better off settling on the other's term than suffering through a strike, but then again, they both still prefer that the other party accommodate to himself or herself. So, if the players knew what strategy the other would choose, the game would be easier. However, there is not. This is still two Nash equilibrium. And to achieve either of these, the players need a focal point or convergence of expectations. Again, I said this is a coordination game. And well, in this example, since they are married couple, there's a hope that they both know each other very well and hopefully meet at the same place in the evening. And also this game has the chance to be played repeatedly since they are married couple. So there's a chance they may coordinate. However, if this game is being played by two players who just met, there's a risk that coordination would fail. And these kind of games actually lead us to evolutionary game theory, which would lead which type of equilibrium would the society end up in the end. Another example is called matching pennies. Again, the players are Alice and Bob. Well, we all play this game, matching pennies. The strategies are heads or tails, and someone called tails and the other one called heads. The thing is, if Alice wins if both coins show the same face. Bob wins if they show different faces. So they both have two strategies, heads and tails. However, in this game, as you can see, the outcomes add up to 0. This is called a zero-sum game. And there are no Nash equilibrium in this game. There's no dominant strategy for either of the players, and there's no Nash equilibrium. So in this type of game, we need to look beyond the poor strategies we have considered so far and consider mixed strategies. In this type of games, the most important principle is what Alice should not do. So she shouldn't do the same thing at all systematically. This is called a mixed strategy. Players need to randomize their choices of pure strategies. And as you can all guess, this type of game ends up with converges to an equilibrium of 1/2. The use of mixed strategies is the whole point in this type of game is to keep the opponent guessing. The solution is randomized between heads and tails. If either of you play this type of game, you sometimes call heads, you sometimes call tails. If you accumulate them, then you would end up with half time saying tails and half time saying heads. The payoffs from a mixed strategy are defined as the corresponding probability weighted average payoff. So it has a different kind of solution system. These kind of games arise in the life too much, for example, penalty kicks. Where would the ball be aimed? How would the goalkeeper react? Should we go to the right, or should he go to the left, or should he stand by? And tennis would be another example of this type of games. So actually, what I would like to say is this: I was assuming that more would join into the playing game part, but none happened. These are all simultaneous games. There are also different kinds of games like sequential games, some games like chess. Some games one play first, the other plays second. Those are involve thinking of backward induction. In that type of games, since assuming that players have perfect knowledge and they are rational, they would look at the end of the game and payoffs, and by thinking backwardly, they would end up with their best strategies. Again, as I said, if there is asymmetric information or imperfect information, those games have different kind of solutions. And I guess that is all from me. Thank you for listening to me. If you would have any questions or any things to say, I would listen happily.
Okay, thank you very much. Any questions or anything to say? No? Okay, why do we need a game theory? That's $1 million worth question. Do we have it? Do we need it at all? What would you say? Well, my question is this, actually, we assume some kind of rationality, but somewhere you said, they need not to be selfish. If I did not miss.
Yes.
So selfishness is usually understood as an important part of the assumption of rationality. So how do we define rationality within the game theory? Is there a general definition, or everything depends on the game itself?
Well, actually, maybe everything depends on the game itself. Maybe we can say we can interpret rational or selfishness philosophically when we are saying that not selfish. It comes up at the prisoner's dilemma, actually. If you are acting selfishly, you would end up with less. You would end up with less jail time. However, when you are thinking about the other parts and how he would react, then you would end up with higher jail time, which leads you to a less payoff than you would have. And may I tell this part Turkish because it would be more convenient for me.
Okay, that's fine.
Ben burada bencilliği aslında birazcık şey gibi, yani bencilliğin kendisi aslında hayatın her alanında var. Yani birisinin mutlu olmasını isterken bile biz kendimiz mutlu olacağımız için onun mutlu olmasını isteriz ya hocam. Sonuçta o bile bencilliktir aslında. Öyle değil midir?
Yok, bilmem.
Bilmem. Bana hep öyle gelir. Farkında olmadan bilinçaltında herhalde karşı taraf mutlu olunca biz mutlu olacağımız için onun mutlu olmasını isteriz.
Ya ama o zaman her şeyi bencillikle açıklamak mümkün. Yani işte ben memleketimi seviyorum çünkü iyi bir ülkede yaşarsam benim için de iyi olacak filan. Neyse. İyi, o zaman bütün bu bencilliği her şeyin başına yerleştirmek iyi bir fikir mi?
Ya o tartışılır işte. O işin felsefe kısmı, o beni aşan kısım.
Ha, yok estağfurullah. Anladım. Yani şimdi game teoride biraz hani şeyleri çok basitleştirerek anlatmak ya da daha doğrusu bir takım stratejileri indirgiyorsun ama genellikle şey de değil. Hani gerçek dünya hep iktisatçılara yönetilen eleştiridir ya, ceteris paribus gibi işlemiyor. Aynı anda bir sürü şey var. Ama game teorinin en azından oyun teorisi diyelim. Madem Türkçe'ye döndük. Oyun teorisi mi, oyunlar teorisi mi?
Oyun teorisi diye geçiyor.
Yani ben de öyle şey yapıyorum ama mesela bazı insanlar oyunlar teorisi diyor. Semih Koray mesela, ki kendisi de oyun teorisi konusunda şeydir. Bu niyeyse öyle oyunlar teorisi diyor. Bu şey gibi, Games of Thrones mu, Game of Thrones muydu neydi?
Games of Strategy olarak geçiyor bazen. Belki ondan dolayı mı oyunlar teorisi diyor?
Olabilir. Ha.
Belki de.
Evet, yani hayata game teori perspektifinden bakmak bize ne kazandırır?
Yani game teori perspektifinden bakmak aslında çok da kolay bir şey de değil. Hani o kadar rasyonel de değiliz gerçekten. Hani limitli rasyoneliz. Çünkü işte anlık duygularla hareket ediyoruz. Ne bileyim, ben restoranda bile önünüze bir menü geldiğinde hani kendi faydanızı maksimize edecek yemeği ararken garson tepenizde dikilirken mesela pat diye oradan bir yemek seçiveriyorsunuz. Hani o kadar da fazla maksimize olmayabiliyor. Dolayısıyla orada gerçekten de bounded rationality şeyi daha fazla aslında. Hani varsayımının doğru olması. Ama işte game teorinin varsaydığı şey şu. Diyor ki sen bounded rational olsan bile karşı tarafta bounded rationalse eğer senin rasyonel olarak atacağın adım seni her halükarda daha iyi duruma getirecek. Dolayısıyla sen karşı tarafı da rational varsay ve ona göre adım at ki daha hani yüksek payoff al. Ama tabii bu hayatta her zaman geçerli olan bir şey değil, yani orası da öyle. Zaten Richard Taylor'ın söylediği şey vardır ya, hani ekonomide varsayılan as if.
Hepimizin yaşadığı sorun.
Ekonomideki varsayımlar hani sanki as if'miş gibi şeyler, gerçek hayat değil. Yani birazcık ona giriyor ama tabii bu varsayımların as if olması bize hiçbir şey vermiyor da değil. Hani gerçek hayatı sonuçta bir teorize etmemize yarıyor. Bir de hani game teori olsun, ekonominin diğer alanları olsun, sosyal alanlar olsun. Sosyal dediğimiz şeyde bütün insanlar ve bütün insanların kararları var. Bu kararların içinde işte herkesin ayrı bir psikolojisi, ayrı bir fikri, ayrı bir deneyimi vesaire var. Bütün bunların hepsini ayrı ayrı modellemek çok çok kolay bir şey de değil. O yüzden bir takım hani böyle solid katı varsayımlar yapılmak durumunda ki hiç değilse teorinin temeli ortaya çıksın. Belki üstüne hani duruma göre bir şeyler eklenerek modellemeler değiştirilebilir diye düşünüyorum.
Anladım. Tamam. Yok şey düşüncesi önemli. Yani özellikle işte o prisoners dilemma. Çünkü iktisatta ne diyoruz biz? İşte herkes rasyonel davranırsa sonuçta Pareto optimal bir dağılım, kaynak dağılımı, refah vesaire olur. Ama işler pek de öyle olmuyor Nash'in dediği gibi, değil mi?
Evet.
Yani insanların kendileri için en iyi seçenek, en rasyonel seçenek diye düşünüp seçtikleri genel olarak oyunun bütünü açısından kötü sonuçlara yol açıyor, değil mi? Mesela trafik kurallarına uymazsak bireysel olarak bu işten kazanırız, değil mi? Zaman kazanırız falan. Tabii herkes öyle düşündüğü için de bu durumdayız filan.
Aynen.
Evet.
Aynen öyle.
Yani fazla rasyonellik de iyi değil diyor sonuçta. Belki.
Tabii.
Anladım. Evet, teşekkür ederiz. Var mı sorusu olan arkadaşlar? Konuşarak Türkçe, İngilizce, chat üzerinden. Yani bu game teoriyle daha fazla karşılaşacaksınız ilerleyen yıllarda diyelim. Zeynep Hoca'dan tabii game teori dersini almanız iyi olur. Seçmeli değil mi ders?
Seçmeli hocam. Evet.
Heh. Yani o aslında insanın değişik seçeneklere ve stratejiye karşı düşünmesini geliştiren bir şey. Bir tür oyun. Josephine'in problemi hakikaten mesela sevimsiz bir problem değil mi?
Evet. Josephine'in problemini Naci Hoca'nın çok kullandığı bir örnekti. O yüzden özellikle koydum.
Anladım. Ha. Neyse. Yani peki son olarak şey sorayım hani bugünlerde biliyorsun Rusya ile Ukrayna arasında bir şey var. Hatta Ukrayna-Rusya meselesi de değil, Rusya ile NATO arasında. Mesela böyle bir oyunlaştırmak, oyun teorisi perspektifinden baksak nasıl bakabiliriz? Tabii
Hocam o
elimizde
konuda
yeterli veri yok, bilgi de yok ama.
yani orada tarihsel bir süreç de var. Onunla ilgili aslında sizinle konuştuktan sonra gazetelerde falan hani acaba oyun teorisi açısından bakan olmuş mu diye baktım. Çok fazla fikir var. Yani Rusya ile NATO arasındaki oyuna bakan var. Bunu simultane oyun gibi teori eden var. Bazıları sıralı oyun gibi yapmışlar. Bazıları Rusya'yı tamamen hani kaybeden olarak gösteriyorlar. Bazıları işte Saddam örneğinde olduğu gibi Rusya hani sonunda kazanacak, batılı bakış açısıyla bakıyor falan diyorlar. Hani sonucunda da çok net bir şey çıkmadı. Hani hiçbirisinin tam bir çözüm yolu da yok açıkçası. Ama sonuçta evet yani oyun teorisinin ilgilendiği bir alan işte yani savaş ve insanların kararları söz konusu. Hani insanların karar vermesi, davranışları, neye göre karar verecekler. Burada dediğiniz gibi hani elimizde çok fazla veri yok. Benim uzmanlık alanıma da girmediği için çok fazla bir şey de
Anladım.
söyleyemeyeceğim ama hani sonuçta işte NATO ne düşünerek nasıl karar veriyor, Rusya ne düşünerek nasıl karar veriyor, hani Putin'in nasıl bir düşünme mekanizması var ve orada Ukrayna'nın davranışı da sonuçta önemli bir şey. Ukrayna şu anda aslında birazcık yani güvercin şahin oyunu gibi bakılıyor çoğu şeylerde, hani kaynaklarda. Ukrayna birazcık güvercin geri çekilmiş, Rusya birazcık saldırı modunda ama hani yalnızca ikisi arasında oynanan bir oyun değil artık.
Değil.
Dış
Değil, evet.
güçler de devreye
Doğru.
girmiş durumda.
Yok hani şey vardır şu Mad Dog stratejisi vardır ya. Eski Fransız de Gaulle mesela hiçbir koşulda bu Avrupa Birliği oluşumunda Avrupa Ekonomik Teşkilatı neyse o zaman geri adım atmaz, her zaman uzlaşmazı oynar, ondan da kazanç sağlar. Putin'in stratejisi de biraz öyleymiş gibi duruyor sanki.
Şimdilik öyleymiş gibi duruyor. Evet ama
Ha.
dışarıdan da çok fazla hani ambargo ban falan yemeye başladı. Değişir mi, değişmez mi?
Yani şey olsaydı bu arada hani kısa sürede bitseydi iyi bir strateji olabilirdi tabii ama uzayınca o şey de çok bir işe yaramamaya başlıyor görünen. Yani hiç kimse bu kadar uzayacağını düşünmüyordu açıkçası.
Evet, evet.
Ha. Evet yani bu ara game teori bütün sosyal bilim alanlarında kullanılıyor. Aslında şeyde de var yani işte biyolojide bu halk doğu işte güvercin şahin oyunu ta eskiden beri Malthus'tan beri şey olan zaman zaman gündeme gelen bir hikaye değil mi?
Evet.
Hem insan davranışlarını uygulamak mümkün, hem biyolojik türlere. Uluslararası ilişkilerde bu ara çok moda. Sosyologlar epey bir keşfettiler oyun teorisini. Dolayısıyla ilginç bir şey. Ama oyun teorisindeki sıkıntı galiba biraz çok fazla oyun yok değil mi? Hep birkaç tane standart oyun var. Ona uygun şekilde. Hani o konuda çok
Evet,
çok
yani
bir gelişme.
anlatılanlar orası öyle. Hatta davranışsal iktisat belki de oyun teorisine geçmiş bile durumda şu anda. Oyun teorisindeki birçok oyun hani deneylerle vesairelerle o çoklu neş dengelerinin bile sonunda işte neş dengesine gelebildiği, bir tanesinin nasıl seçildiğini falan çalışan bir alan var. Dolayısıyla oyun teorisi belki davranışsal iktisattan sonra birazcık geri planda kalmaya başladı. Orası doğru, evet.
Hmm. Ya da en azından hani davranışsal iktisadın bir alt dalı haline de
Dalı.
dönüşebilir. Bir de tabii oyun teorisiyle uğraşmak zor. Matematik bilmen lazım filan.
Evet,
Aslında
orası.
yani evet, hepimizin yaptığı şeyler biraz, ama işte işin içine biraz matematik vesaire girince şey yapıyoruz. Ha. Neyse. Başka sorusu olan, bir dakika, chatte bir takım şeyler var. Neymiş? Yok, teşekkür
Teşekkürler.
ederiz. Hadi git diyorlar. Evet. Tamam. Çok
Salın
çok
bizi hocam diyorlar.
aynen öyle. Tamam. İyi. Çok teşekkürler Zeynep. Sağ
Ben
olasın.
teşekkür ederim hocam
Gerçekten
davetiniz için, sağ olun.
güzel, ilginç bir sunuş oldu, ama benim işte internet bağlantısı sorunu, inşallah şey yapmaz. Ona bir bakayım. Şey yaparız. Konuşuruz gene.
Tamam.
Zaten bu hafta tekrar görüşeceğiz inşallah.
Evet. Evet.
Tamam. Çok teşekkür
Görüş.
ederiz.
Ben
Bize
teşekkür
vakit
ederim.
ayırdığın
Görüşmek üzere
için.
hocam.
Sağ ol. Görüşmek üzere.
Hoşça kalın.
Hadi görüşürüz. Evet, kimsenin sorusu yoksa ben de gideyim artık. Yok. Peki. İyi. Hadi o zaman kendinize iyi bakın.